Why would you?
All right, here we go. Questions on the homework. Questions on the homework. Seems like there's some people not here today. Grayson, who else? Winter's been absent for a couple days.
Jackson's gone. Winter got COVID now.
No, she didn't.
I'm joking.
She does, she die. Bruh. You ever think of that?
Oh, that went dark awfully quick.
She, but I'm not wrong. She's a higher chance of dying than any of us here. What are you talking about?
How about we focus on some math instead of what probably is not happening? All right.
Really?
Okay, any questions? I had a number of people came to me during student advisement yesterday. I explained all. They're like, "Oh, okay, I get it. The big idea with permutations, you get that weird looking thing, something, something. The first number is how many things you have to choose from. The second number is how many you're actually choosing. That second number I always call my fingers. The second number, if you're choosing 4 of them, I hold 4 fingers up, and let's say you start at 20, so it would be 20 times 19 times 18 times 17. That's how it's done. Yes? Yeah. You will see that again today, so you get more reinforcement on it.
Can we do number 8? No, wait, no. Where is it? Oh, number 10.
On which one? Problems or written exercises? What?
Written.
Number what?
Number 10.
Number 10 says 23, choose 2. 23, choose 2. So how many fingers do I need to hold up?
20.
It says 23P2. By the way, there is a button on your calculator that will do this for you. 23P2.
Isn't it 8P?
This is how many fingers you hold up. And you don't have to use fingers. I need 2 choices, and I'm going to start with
23.
23 times,
22.
and you're done.
Wait, I did 21.
That's why it's done. This is how many you're choosing. This is the number you start with. I need 2 numbers starting with 23. 23 times 22, done. If this number is a 4, then I need 4 fingers. 23 times 22 times 21 times 20. Yes.
So on the 10, are you gonna like how far are you gonna have like
Giving you a 2 would be a perfectly fine test question because that's not that big of a deal.
you're not gonna do
Giving you a 23, choose 23, that's not a test question. That's a calculator one. By the way, your calculator is
like it's stuff that
pretty big number.
you'll be able to do.
Remember, we did 30, choose 30 yesterday. And we found out it had 32 zeros in it, right? I'm sorry, 30, choose 30. And we found it had 32 zeros in it. All right. Yes. Which one? Written or problems? That was
Yeah.
number 12, yes.
I asked for number 10.
I can't hear him with you. Everyone's talking. What? He said 12, didn't he?
No, I said 10.
10 is 8, choose 4. So I need to start with 4 choices. I'm starting with
8.
8, 7, 6, 5. Multiply together. Okay. All right, here we go. Very quickly. 2 through 12 evens written. Number 2 is 720. Number 4 is 40,320. That's 8 factorial. That's crazy. You're already up to 40,000. Number 6 is 5,040. 5040. Number 8 is 506. Number 10, 1,680. Number 12, 506. And then we have 2 through 8 evens on the problems. Number 2 is 6. Number 4 is 12. Number 6 is 18. And that question made me very hungry.
I was 1 through 8 all. No.
It says
No,
evens.
even.
Wait, number 6 was 18?
18.
I have 5,000.
You have 3 types of bread, 2 types of cheese, 3 types of meat.
Wait, what?
3 times 2 times 3.
You said written, right?
Okay, can you repeat that again?
It's right there.
Yeah.
The last one, number 8, is 6. 6.
I thought they were-
I got 9.
All right.
What was 6, 4, and 2?
I just closed my book. All right, Christian's going around to grab your stuff. And Craxton is going to hand out. Yes. I was trying to slaughter both your names. All right, hey, I'm not going to lie to you. Hey, today is not a day to mess around, not pay attention. Big picture, it's not that bad. It is a formula. It's a weird formula. I promised you at the end of class I would show you the button on your calculator. I will today. But you got to be able to do this by hand. There's no calculators on the test. So just because I show you where the button is on your calculator, great. You got to be able to do it by hand. You have to be able to do it by hand. All right. Homework for over the weekend is as follows. Kai, make sure you look at that carefully. What does it say? Does it say written exercises or does it say class exercises?
Written exercises.
Oh,
Clearly, one person, Landon, did not even attempt to look at it.
Written.
It says written, it says class exercises. Now you got me making a mistake.
Written exercises. No.
And then it says problems. So no written exercises. No written exercises. I don't believe this one has written exercises. So.
Am I included in the problems?
No.
Jinx.
Okay. I said today was, it's actually not too bad, but it's weird. You've never seen it before. You don't know the concept. It's got a different formula. It is a slightly messy formula, slightly. Once you do about 3 or 4, you should get it. It's not that big of a deal. Okay. And then as long as there's time, I'll show you the button on your calculator.
I know.
Unless you have a dollar calculator, then you don't have that button. All right, here we go. Yesterday was permutations, today was combinations. All the problems yesterday dealt with how many different ways can you arrange, where the order mattered. Okay. Yesterday I gave you 3 shapes and I said pick 2, right? If you pick 2 of those shapes and order does not matter, we called those combinations. When order does matter, more of them, we call those permutations. And we got a formula yesterday that was that, they call it the NPR formula. Okay? All right, real world example. Your mom says you can go to the movies and you can bring 2 friends. Okay? I don't care which 2 you pick. If you pick Bob and Sue, that's the same as picking Sue and Bob, right? When you pick friends to go with you, those are combinations. Okay? When you get to the movie, you sit down in a seat, well, then you can arrange them in a specific order. As soon as you pick your seats, those are called permutations. This is a hard concept. When you get to the test day, I'm going to give you a scenario. You're going to have to figure out whether it's combinations or permutations. You simply ask yourself, does order matter? You choose 2 friends, the order doesn't matter. You just need 2 friends. But to pick a seat, there's a specific order going on there. That's the easiest example of combinations and permutations. We better write this down one more time because you guys probably have forgotten this. So same thing as we wrote down yesterday, I'll make you do it one more time. So permutations and combinations. Permutation is where the arrangement is in a specific order. It goes circle, square. Circle, square is not the same as square, circle. But if I tell you to pick up 2 toys, well then circle, square is the same as square, circle. If I say put them down in order, we're talking permutations. There are always more permutations than combinations. More permutations than combinations, unless you're choosing one thing. You choose one thing, then there's the same number. I don't have any examples where we only choose one thing. Permutation, it's arrangements of the things in a specific order. Combinations, no specific order. For those of you looking at your homework trying to figure it out, it's a little complicated. Be careful. Once you see 1 or 2 examples, it's not that bad.
I figure out the fun.
You got it. All right, we okay? Same thing we wrote down yesterday. All right, recall. The permutation notation that we had from last night. That was the NPR. It's weird. Well, the P isn't weird. It stands for permutation. If the N and the R, they're not very descriptive. N stands for how many things you have to choose from. They got 52 cards, so there's 52 cards to choose from. The R stands for how many of them you're actually choosing. I don't know, you play poker and you're playing 5-card draw or stud or whatever. You draw 5 cards out of 52. You got 52 cards, you're choosing 5 of them. How many cards you draw when you play Uno? I don't know. I've played Uno. 7. So I don't know how many Uno cards there are, but 52, choose 7 of them. Last night you did that calculation to find out how many different ways there are. There's 52 and you're choosing 7 of them. There's a lot of possible permutations there. Lots of them. All right, I didn't ask you to write this one down. All right, one quick example. You got 9 friends and you can have 3 people sitting next to you in the movies. Remember, choosing a seat would be an order. If Sue is sitting on the left or sitting on the right, those are 2 different choices. You bring Sue to the movies, that's one choice. Order doesn't matter.
Okay,
As soon as you take a seat, that's an order.
I got a question.
What?
How do you have 3 friends sitting next to you? And they are.
Well, you get the basic idea.
I
Right.
mean,
Well, yeah, we're not literally talking about left and right then, obviously. Okay. So you got 3 friends and they're sitting next to each other at the movies. How many different ways can this be done? In other words, 3 people, 1, 2, 3. How many different ways are these 3 people can sit next to each other? Well, we got to throw them into the NPR formula, right? Remember, you originally chose from 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So these were the 9 people. 3 of them get to go to the movies. If it's these 3 people, now you're at the movies. How many different ways out of the 9 can these 3 people sit down? Well, it's 9, choose 3. You don't think it would be a lot. It ends up being a lot. How many fingers do I hold up? And I don't mean literally fingers, but you know what I mean. There's 3 choices. So that's
9,
times,
8, 7.
what's 9 times 8 times 7? That's a lot of different ways. A lot of different ways. I don't know if you have 9 friends, but there's 504 different ways that they can sit down. There's 504 different ways that those 3 people can sit down.
Like in a row, like this.
Like in a row.
You fit like 1 person.
504 different ways. Now, why is it so large? Because remember, you're choosing from 9 people. So she can sit here, or she can sit here, or she can sit there, or she can sit here, or she can sit here, or she can sit. You know, that's what's really going on here. Okay. The fact that I chose these specific 3, right?
it's because they talk.
No. Okay. So that's an example of permutations, order matter. Today we're not doing permutations. Today we're doing combinations. There's fewer combinations than there are permutations. Pick 3 friends, right? It doesn't matter which 3, right? Doesn't matter whether it's Bob, Sue, or Harry, right? That's the same 3 people regardless of how I flip them around. If I'm choosing 3 friends. So C, choosing, right? Combinations. Okay. So today we're doing this top row right here, combinations. There's fewer of them. Okay. All right, so don't panic. This is a complicated formula. Once you do a couple examples, it's not too bad. Yes.
Are we gonna do this with fractions?
Well, the formula that you're about to see is a fraction. So could we throw it in? And this year we are restricting ourselves to whole numbers, positive whole numbers at that. Okay. So to answer your question, no. So in box 2, write this down. Not only is this the notation, I'm going to show you the formula. Okay. Technically, the NPR is actually a formula as well too. I just chose to call it notation. Okay, so here we go. It's not a leap of faith to guess that the first thing we need is not a P, but we need a P was permutations. We need a C. So write that down. That's the notation. How do you know it's different from permutation? Capital letter C, right?
Oh.
Guess what the N stands for?
Notation.
No. How many things we're choosing from? Hey, there's 52 cards to choose from. Guess what the R stands for? How many you're choosing. All right, now comes the pain. You ready? On the other side of this equal sign is what the formula is. It looks like the previous formula, but it's more complicated. So here we go. Just write it down. The formula for combinations is NPR over RPR. NPR over RPR. Well, what did R stand for?
Rotation.
How many you pick? Well, I gotta give you an example. N, remember, stands for how many things are there to choose from. R stands for how many you're choosing. Okay? Oops. That goes for every N you see up there. That goes for every R you see up there. Easily forgettable formula. P here does still stand for permutation, so here's the paradox. To find out combinations, you find out permutations. Crazy. Okay, so the only thing we have left now is to do examples. Everybody have the formula written down? All right. It's probably best that you watch me do one first. You got 4 friends, lucky you, right? You can take 3 of them to the movies. How many different groups can you bring? Does order matter? No. Doesn't matter. We're not picking seats, right? So this is a combination one. So for a combination one, we need 2 numbers. We need how many to choose from and how many you're choosing. So how many are we choosing from? How many are we going to choose? So I have 4 friends and I'm picking 3 of them. So that would be 4, choose 3. But that 4 and the 3 need to go everywhere there's an N and an R. So that needs to be a 4, that needs to be a 3, that needs to be a 3, that needs to be a 3. That's a lot of work. N is your number to choose from. R is how many you're choosing. You see what I did? Now it looks like last night's homework. The top part, the numerator. 4, choose how many? That's 4 times, what's 4 times 3 times 2? The bottom says 3, choose 3. So that's 3, and I start with 3. 3, 2, 1. Here's it all written out. You see what I did? Yeah. Now let's do the math. Oh, would there be an easier way than doing the math? What would be the easier way?
Do 6 and then.
How about we reduce? I mean, you can multiply. So what reduces here?
2.
The 2's cancel.
3.
The 3's cancel. So what are you left with?
4.
Well, that wasn't too bad. So if you have 4 friends and you choose 3 of them, there's 4 different ways that can happen. That's not permutations. By the way, permutations would be 12, 24. There's 24 different permutations for them to sit down, but there's only 4 different groups of 3 that you can choose. Okay? We need to see some more examples, right?
Yeah.
Okay. Here's another one. Cards. You got 6 different cards. You're choosing 3 of them. Well, how many different ways can you draw 3 cards if there's 6 to start with? Step number 1 is to determine whether it's permutations or combinations. It's easy today. They're all combinations. Okay. There's 6 to choose from. I'm choosing 3 of them. 6 to choose from. I'm choosing 3 of them. So we simply need, anywhere there's an N, we need to write
6.
Anywhere there's an R, we write.
3. Oh.
And we do the math.
Oh.
Top part, how many fingers am I holding up?
6.
3. It's always this number. I'm going to count down from 6 times 5 times 4. And on the bottom,
3.
3, 2, 1, right? You'll find this pattern all the time. The bottom number is always going to be that number count down to 1. In fact, it's just basically factorial. Other books, instead of writing that, they will write n factorial. Our book doesn't choose to do that, it chooses to write that. All right, anything cancel?
No.
How about this 3 and the 6? 3 goes into 6 how many times?
2.
And then guess what you can do with that 2?
You can make it into 1, 2.
Cancel it out with this 2. So what are you left with? Which is,
20.
okay, that's a lot. 6 different cards. There's 20 different hands that you can have in your hand. You draw 3 of them.
Okay.
Okay. Feeling a little bit better?
Yeah.
Okay.
Wait, so like for the end, how do you like have like for the homework, the N and the R are probably not gonna be above that?
Right. That's the best question. Yeah, they're not going to make it nice and
How do
colorful.
you-
You got to think it through logically. Typically it's a game or a scenario or something like that. You think of, well, how many different choices in total do I have? If it's a game, you know, how many cards do you have? How many dice do you have? How many whatever?
Is the keyword for R like
It'll say how many you're choosing. Like you can literally like, obviously this isn't the word choose, but draw would mean choose, right?
and that would be
That would be your R. Okay, let's do one together, box. What are we on? 3? All right, here we go. Box 3. Well, luckily for us, it literally says how many combinations. That makes it a whole lot easier, right? How many combinations of 2 cards can you get if you have 8? Okay. 2 cards if you have 8. So which one is the N and which one's the R?
N is 8 and R.
N is your 8. That's how many cards we have. You're choosing 2 of them. Now just plug those numbers into the formula. For those of you that become very familiar with this, you might start doing some of this math in your head. Be careful with that. How about you just write it out? All right, Kai, what's the numerator turn into? 2 is how many fingers. 8 is how many you start with. So what am I going to write in the numerator? 2 is how many fingers. 8 is the number you start with. 8 is the number you start with. Literally, start with 8.
Yeah, 8.
You
Oh,
said
8,
6.
7,
What? 8, 7. There you go. What number are we starting with?
2,
And how many numbers am I going to say?
1.
2, 1. What cancels? 2 and the 8. The 8 turns into a 4 times 7 is
24. 28.
28. That's a lot, right? You got 8 cards. You're drawing 2 of them. There's 28 different ways of picking 2 cards. This is why you should never gamble, right? Because there ends up being so many possible combinations. You think, oh, I got 2 kings. I just need to draw 1 more. It turns out it's nearly impossible, right? Oh, sure, it happens once in a blue moon. Or someone else gets it. You're like, oh, maybe I'll be next. Well, we'll calculate probability as well in this chapter. All right, next one. Okay, this is that game of you got a bag and there's letters inside the bag. All right, how many letters we got to choose from?
6
Or 7.
or 7.
1, 2, 3, 4, 5, 6, 7. And how many are we choosing?
3.
What? 3 of them. Okay. So I'm choosing 3 out of 8. 3 out of 8.
No, 3
7. Sorry, why did I say 8? 3 out of 7. 3 out of 7. Do I need to pick on Kai again?
Yes.
Kai, what's the numerator turn into? Keep talking. All right, he's got it down. The bottom one is the easy one because it just always goes this number all the way down to 1. 3, 2, 1. Okay? That's only for combinations, not permutations. By the way, the top is the permutation one, so you're getting like practice doing permutations even here. All right, what cancels? 3 and now if you're thinking ahead, you cancel with a little bit of thought process. If we turn this 6 back into a 3, then nothing else cancels. This is a sneaky way of doing it because I kind of know what's going to happen. I'm going to, instead of doing 3 and 6, I'm going to do 2 and 6. Watch what happens.
3.
And then the 3s cancel. It's not that you can't do it the other way, right? It's just that this way clearly is a little bit easier. 7 times 5.
75.
And by the way, you don't have to do any canceling or reducing. You can multiply straight across and then reduce. Yeah.
Would it be fair that the smallest number would always be the bottom?
What do you mean the smallest number?
The smallest number will always.
Oh, yes, that will be fair. You're right. What he's saying is You're always going to have two numbers up here. Would it be fair to say that the smallest number will be the second number? And the answer is yes. Because you can't have 3 and choose 8, right?
Like, so we're gonna multiply you guys by 5 now.
Right.
You become 8 people.
All right, one more. Box 5. How many ways can 2 people be selected from 20? All right, this is, I mean, like literally a class, and I say I need 5 volunteers. So the question is, how many different ways could I arrange you guys into groups of 5? Right? And by the way, we have 30 people here, not 20. Okay. So what's the formula?
2,
What's the formula?
P, whatever the thing.
NPR over RP.
NPR over RPR. Now plug in the numbers. 20P2 over 2P2. Okay. 20P2 over 2P2.
So 21, 19.
Neither one of those.
What?
You just changed the color.
Did I?
Yeah.
No, I really tried not to do that, but I guess I did. You're right, I did.
What? Why not?
This is the
19?
number you start with.
Yeah, so it's 19.
No, you didn't.
I said 20 to 19.
No, you didn't. Now you did. So what do you want me to write on the numerator?
19.
No. Say it again.
2019.
Thank you. It's important that you write it that in that order. Okay. 2019 on the bottom. Go ahead.
Oh, 2 and 1 on the bottom.
What cancels?
22.
And that 20 turns into a.
4.
Take a deep breath. Therefore, the answer is. You do that in your head. You got it. That's crazy. If I had to pick 5 people out of you, and that, by the way, there's 30 of you, it would even be bigger. You would be 30 times 29 over 2.
Why 29? Now we get 30.
30 times 29 over 2. Right. If I choose 2 people out of the 30 that are here, right? I don't know what that is, but it's a pretty big number, right? There's only 20 of you. There's 190 different possible ways of choosing 2 of you. I need 2 people. Well, let's see. There's 190 different ways I can choose that. That's crazy. That's out of 20, not out of 30. Yeah.
Wait, where did the
Remember, this is your starting number, and I need to choose 2 numbers. 20, 1 less, 19. 20 times 19. You're still like got that look on your face, like I don't know what he's talking about. So this is the number you start with, the number on the right, that's the end, and this is how many numbers you're choosing. And you always start with the highest number, count down by 1. If I'm choosing 5 of them, I got 5 kids now, 20, 19, 18, 17, 16. Okay. We got this? Okay. See if you can do this one all by yourself. Go. It's the last one.
I bet I got right.
And then I'll show you the button on your calculator. Did you use your calculator? Yes, you did.
Okay, yes.
You've done none of this.
I understand though.
No, you don't. If you've not done it by hand, you've used your calculator for each one, you have no clue.
You do the, so like for this one, I take 3 and I put right here. And I take, no, sorry. I put
Why don't
5
you do
here.
it quietly and show me your math on it?
Without your calculator.
Pick 3 questions
Yes.
and a 5.
Are you just stretching?
Yeah.
Okay, look like you're asking questions.
P, 5, 3.
Josh has to pick 3 out of 5 questions.
Wait,
The teacher says, hey, here's 5 questions, just choose 3 of them.
Yeah.
How many different ways can you arrange those 3? So he's got 5, choose 3. 5, choose 3.
Wait, I got it wrong? Oh, I got it.
You haven't written the answer yet. So let's see. 5, choose 3 would start with 5, count down 3. So 5, 4, 3 over 3, 2, 1. What cancels?
The 3 and the 2 and the
3s and the 2 and the 4. Therefore, you are left with,
10.
there are 10 possible choices. Not that many. All right. Now we got lots of different calculators out there, but there's a lot of these. TI-30.
Yeah.
The magic button. Well, actually, let me show you how it's done first. To do it, This is, look up here, please. This problem right here is a combination. So even though this is how you do it by hand, on a calculator, we're looking for that button right there. And we need, what, 5, choose 3, right?
You didn't show that.
I will talk, just listen. It's like I start the sentence, you're like, what do I do? Let me finish talking. Okay, one calculator at a time, TI-30. The way you type this into a TI-30 is you type in 5. So put a 5. The button that you are looking for a TI-30 is on the top right, PRB, that stands for probability. Hit that button. You get 2 choices. Oh, and by the way, there's the exclamation point for last night's homework as well. Obviously, we want to arrow over to NCR because we're doing combinations. Hit enter. And you can say it's now it says 5, NCR, hit a 3, and then hit enter, and you get 10.
Wait,
All right.
I didn't read that.
You got to do 5 first, then probability.
Where's that?
Scroll up. Stop. Seriously, one calculator at a time. To NCR, enter, and then 3. Enter. There you go. All right, everybody has a TI-30. We good?
Yeah.
All right. For those of you that have a graphing calculator, right, a bunch more buttons to push. It's under math. Over here, scroll over where it says probability, and you'll see down below it says NPR, NCR. There's your exclamation point as well too. Now type a 3 and hit enter. Who else has got a different calculator?
I got this one.
If you have that Casio, I got to Google that one. I don't know. I'm going to Google this one. I don't know the Casio. I guarantee you it's on this. Sometimes it's literally.
It's only up for
Sometimes you guys use some search.
Orange +5.
It does, but sometimes, like, here's your exclamation. Sometimes you'll
The next
see
one's
on
like a green.
NCR, NPR.
Like
Here
a
they are.
blue, like teal.
So it's the
I'm
same
right,
thing.
aren't I? Show me the cut. You just made it.
Shift, where's your shift? Shift, here's your NCR.
I bet he probably switched it back to
The red,
red.
it's red.
Or the orange.
You don't need.
I was technically right.
All right, we good, calculator people?
Yellow, another green has this.
That's,
No, like that's the color I'm
Oh, green.
yellow. Yeah.
it's on here somewhere. I bet it's under.
It's yellow.
You probably have to go to stats or.
Why are you giving me that?
I'm gonna have to look this one up. I don't know this one.
It's a yellow version.
I don't want to.
Sometimes it's written directly above. This one is not.
Here, guys, what color is this?
Sometimes we're looking for probability.
It's like red. Did I guess red right?
Oh, shut.
3.
How do you do that?
Give me a chance to go. Okay, let me wrap this up. By the way, hopefully you saw where the factorial button was on when you're messing around that. For all the people with the TI-30, it's that same menu, PRB. It's the third option over. So everyone can do that calculation. Do 30 factorial. And that's how many different ways you guys could sit in these seats right now. Do 30 factorial. That would be 30, choose 30 as a permutation.
2.6525.
And 32 zeros or 31 zeros after you move the decimal place. That's crazy. I don't even know what that is as a number. Like, I don't know what 32 zeros. I know 6 zeros gives me a million. 9 million gets me a billion. 12 would get me a trillion, and then I'm lost. Quadrillion. But there's 32 zeros. We're up to 3, 6, 9, 12. I need 19 more zeros. That's just for you guys to come in and sit. It's crazy. That's how many seat positions there are in this class, if there's 30.
We'd be here for like 4
You,
years.
You could probably, we could probably do the math there. You could probably change your seats every minute for the rest of your life, and we would still not have enough
Let's do it.
minutes.
How about seconds?
Well, let's see. Well, let's do the math.
That's a way to.
How many minutes in a day?
64. Oh no.
60 in an hour times 24. Listen, please. Times 365. How long do you want to live?
80.
100 years? All right. Multiply this. You got a calculator in front of you. 60 times 24 times 365 times 100. Did you get times something to the 32nd power? Because remember, if we change every minute, we have, what that number was, 2.6 times 10 to the 32nd power?
It was more.
Well, what did you get when you multiplied that? If you get that exact same number, that means we could do it every minute for the rest of your life. By the way, you have to start the minute you're born. The answer is no, you don't get a number that's big. I'm just saying, if we change seats every minute from the day you're born to the day you die and you live to 100, we would still have more seat possibilities. That's just for 30 people. That's crazy.
Unless you're the Flash, then everybody's the Flash. and
You're the
everybody's
Flash, and you can do it quickly. Yeah. All right, that'll wrap it up. Have a good weekend. See you on Monday. All right, no e-learners, but e-learners, if you do have a question, let's send me a chat or email.